All right, let's talk about something that's quietly running our entire world, but you probably never even see it. It's called computational modeling. And it's basically the invisible architecture behind, well, pretty much everything, from your phone to huge government decisions. So let's pull back the curtain and see what's really going on. First up, I want to show you just how common these things are. You're already using them every single day, and they often work so well you don't even realize they're there. So, let me ask you a question. How do you make sense of something impossibly complex, like finding your way across a huge city you've never been to before? Or even just figuring out if you should bring a jacket when you leave the house? Well, here's the thing. Whether you know it or not, every time you do something like that, you're using a model. Yep. I mean, think about it. The map on your phone? That's a super sophisticated model of the real world. The weather forecast? That's the output from a gigantic model of our atmosphere. Heck, even the simple fact that your grocery store has fresh food on the shelves, that's all thanks to incredibly complex supply chain models running behind the scenes. We completely depend on them. Okay, so we're all using them, but what exactly is a computational model? Let's get a proper definition and see how it takes us way beyond just our normal gut feelings. At its heart, a model is just a simplified version of a real-world system that you can run on a computer. It's an abstraction, right? But its real superpower is that it lets us experiment. It lets us ask those what-if questions. What if we try this new traffic plan? Or what if a hurricane takes this path? We get to test all our assumptions without any of the real-world consequences. And this right here is the key difference. We all walk around with common sense models in our heads based on intuition, but a scientific model is a whole different beast. It forces you to write down your assumptions, to back them up with actual data, and to test them over and over again. And for really big, messy problems, that jump from common sense to a scientific model is absolutely crucial. This quote just nails it. The process of actually building the model is where so much of the value is. You can't just wave your hands and say, I think this will work. No, you have to be crystal clear about what you're assuming, and just as important, where the limits of your model are. That discipline is what makes them so powerful. So enough theory. Let's get into the real world, because this is where models go from being an interesting idea to a tool that makes incredibly high-stakes decisions that can change history. And I'm not being dramatic here. The stakes could not be higher. We're talking about policies and choices that literally affect people's lives, our national security, and our collective well-being. This is serious stuff. Okay, just look at this. This is an incredible example from the 2001 foot and mouth disease outbreak in the UK. Scientists modeled different ways to handle the crisis. The model predicted that 2 of the policies wouldn't be enough, but it showed that policy C, a very aggressive strategy, would actually stop the epidemic in its tracks. The government listened. They adopted that exact policy. And look at the dots. Those are the real-world results. They track the model's prediction almost perfectly. That is a direct line from a computer model to saving an industry. And the applications are just all over the place. Way back in World War II, models helped figure out the best size for shipping convoys to avoid U-boats. Today, governments use them to test drive policies before they're rolled out to the public, and cities use them to predict air pollution and send out health alerts. It's everywhere. But, and this is a really, really big but, models are not magic. They're incredibly powerful, for sure, but they are not perfect. And to use them right, we all need to become what the source material calls an intelligent customer. This one line says it all. A model can be your best guide through a complex problem, or it can lead you completely off a cliff. It all depends on how it's built, and more importantly, how it's used. And here is a perfect cautionary tale. Back in 2012, a huge UK rail contract competition just completely fell apart. And a major reason why was that a model built for one very specific job was basically stretched and shoved into a new role it was never designed for. It's a classic case of what goes wrong when you don't respect the tool. So how do we stop that from happening? Well, we have to ask the right questions. And this isn't just for the experts. We all need to be asking, what is this model actually for? What are its assumptions? What are its blind spots? And crucially, can you show me the proof that it's been properly checked and tested? All right, so that's where we are now. But if you think this is powerful today, just wait. The whole field is on the verge of a massive revolution. Let's take a quick look at what's coming. It seems to be heading in 3 main directions. First, we're going to see computers start building models themselves using things like machine learning. Second, The line between the model and the real thing is going to get blurry as we start plugging real-world software right into simulations. And third, models are going to get a lot more human-centric, powering things like hyper-realistic training simulators or incredibly complex video games.
Now, that first point about machine learning is a huge deal. See, traditionally, a person has to tell the computer the rules of the system. With machine learning, you just dump in a ton of data, and the computer figures out the patterns and rules for itself. The only catch? Sometimes it's a black box. It can tell you what is going to happen with scary accuracy, but it can't always tell you why. It's like a genius who gets the right answer every time, but can't show you their work.
And that leads us to the final and maybe the most important question of all. As we hand over more and more of our world to these powerful, sometimes unexplainable models, who's responsible when they get it wrong? That's the question we're all going to have to figure out an answer to. Thanks for tuning in.